In how many ways can you arrange these three items A, B, and C? Say A occupies the first place, then the second and third could be either B and C, or it could be C or B. So we have two ways of arranging these three items when A occupies the first place. If B occupies the first place, then it could be A and C for the second and third, or it could be C and A for the second and third, right? So again, we have two arrangements possible. Now, if C occupies the first position, then again there are two ways, right, in which A and B can occupy the second and third positions, right? So adding all of this up, we get six ways of arranging these three items A, B, and C. Now take another example. In how many ways can you arrange these four items, A, B, C, and D? Say the first item is D, right? Let's say D occupies the first place. Now we need to fill up this three remaining places, right? So this could be occupied by A, B, and C, or A, C, B, or B, A, C, and so on. We saw here that A, B, and C can be arranged in six ways, right? Three items basically can be arranged in six ways. So if D occupies the first place, then we can have six such arrangements, right? When D occupies the first place. Now, if A occupies the first place, then B, C, and D can again rearrange themselves in six ways, right? So again, if A occupies the first place, then again we have six ways of arranging them. If B occupies the first place, then A, C, and D can also arrange themselves in six ways. If C occupies the first place, then again we have six. So adding all this up, we have 6 plus 6 plus 6 plus 6, basically 4 times 6 is 24. So there are 24 ways in which these four items can be arranged. So what we're trying to do here is trying to find a pattern for how to count arrangements of a given selection, right? So we can follow this steps to count the number of arrangements. So the first step is draw the number of places that need to be filled up. So for these four items, we have four places. So that's the first step. The second step is start filling up the places from the left hand side. So it's important that you always start filling up from the left hand side and not from the right hand side. The third one is find the sample size for the first place. So sample size means how many items can the first place occupy, can be filled up in. So the first place can take either A, B, C, or D. So we have four as the sample size for the first place. Now the step number 4 is find the sample size for the second place. Now since one of the items is taken by the first place, we are left with three remaining items, right? So any of the three remaining items can occupy the second place. So the sample size for the second place is 3. Similarly, the sample size for the third place would be 2, right? Because this place also takes up one of the three items. Now, the third place takes up one of the two items, and so for the fourth place, we are left with the remaining item. Now, then what we do is the number of arrangements is basically just the product of the sample sizes for all the places. So we just have to multiply this to get the number of arrangements. So this is your 4 factorial or 24. This is what we found here, right? Now, let's take another example. Say, how many 5-letter words can you form using all the alphabets of the word water? So, again, coming back to the steps for counting arrangements, we first draw the number of places that need to be filled up. The number of places that we need to fill up are 5, right? We need to form 5-letter words. And the second step is start filling up the places from the left hand side. Okay, and the third step is find the sample size for the first place. So the first place can take any of the 5 alphabets. So we put in 5 here. So now we are left with 4 remaining alphabets, right? One of the 5 alphabets is taken up by the first place. So this one takes any of the 4 remaining alphabets. And notice that we do not repeat any of the alphabets, right? So because 5-letter words we have to form using all the alphabets of the word water. So this one has only four remaining options, right? Because the fifth one of the options is already taken by the first place. Now the third place has three remaining alphabets to choose from. The fourth place has two remaining alphabets to choose from, and the fifth place has got one. So to find the number of arrangements, we just multiply it. So we get 5 factorial, which is 120. So this means we can form 120 5-letter words using the word water where none of the alphabets is repeated. Take another example. So how many 4-digit numbers can you form using the numbers 1, 2, 3, 4, 5, 6, 7, such that no digit is repeated in the 4-digit number? So again, step 1 is find the number of places that we need to fill up. So we need to form 4-digit numbers, so there are 4 places that we need to fill up. Now, what is the sample size for the first place? It is 7, right? Any of the 7 digits can occupy the first place. Now, since no digit is to be repeated, the, the second place has only 6 remaining options to choose from, right? 6 remaining numbers to choose from, because the one of the numbers is already taken by the first place. So 6 goes here. Now we're left with 5 remaining numbers to choose from, and then 4 remaining digits to choose from. And then we multiply them to get 7 into 6 into 5 into 4, which is something. So basically, this is the 4-digit numbers that you can form using the numbers 1, 2, 3, 4, 5, 6, 7, such that no digit is repeated. Take another example. How many 4-digit numbers can you form using the numbers 0 to 7, such that no digit is repeated? So again, we have 4 places to fill up. Now, the interesting thing here is, what is the sample size for the first place? Now notice that we have 8 digits to choose from, right, from 0 to 7. But if we have to form a 4-digit number, then 0 cannot be in the first place, right? 0, 1, 2, 3 is not a 4-digit number, it's just a 3-digit number. So this means 0 cannot occupy the first place. So the sample size for the first place is 7, any digit from 1 to 7. Now, so one of the digits is gone. Now we are left with 7 remaining digits, right? Because after all, we have 8 digits. 1 is occupied here. So we are left with 7 remaining digits, and 0 can occupy the second place, right? So we're still left with 7 digits. Now for the third place, we are left with 6 remaining digits. And for the fourth one, we are left with 5 remaining digits. And so the answer is 7 times 7 times 6 times 5. So this many 4-digit numbers we can form using the digits from 0 to 7, such that no digit is repeated.